All right, good morning, everybody. Wanted to thank everybody for taking some time out of their Wednesday morning to join us for our R&D Technologies J850 Capabilities webinar. Wanted to just give you a quick overview, a little bit about our company before we jump right in. So R&D Technologies, we are based in North Kingstown, Rhode Island. We're very unique in that we're one of only about 6 or 7 in the North American region that has a GMN, which is a global manufacturing network. So we are a full partner. What that means is we're a full parts provider for Stratasys, backed by Stratasys, with all the FDM and PolyJet capabilities that is under their umbrella. So we're excited to work with a lot of different companies out there utilizing these capabilities. It's exciting to us to open up new direction with different companies showing us new applications that require some of the unbelievable capabilities that the J850 has to offer. So we're going to take you a little bit more in depth today and talk a little bit more on what the J850 has to offer for its capabilities with regards to full color, mapping, textures, different fields of durometer, flexibility, shore values, grip simulation, overmolding, living hinge. So there's quite a bit of capabilities that you're going to be able to take a look at. Today, we're going to focus a lot on the medical industry and it'll give you a nice overview on what we have to offer, not just in the medical industry, but what we have to offer for the range of capabilities that it has, within its GrabCAD software. So I want to introduce everybody quickly. Jordan Novak will be hosting in our chat room. So we're going to keep this a little bit unique with an open forum. So if you have questions throughout the webinar that you want to ping Jordan with, we are happy to kind of talk to you and answer your questions as we're going through the webinar, so that if it's relevant or specific to your needs and applications, we'd like to kind of jump on that question and it might pop up as Matt presents something that we don't want you to forget your question. So certainly put that right over to Jordan and he will give you an understanding of, hopefully we can answer your questions. In another part of our webinar, we will have some pictures, we'll have the parts displayed out for you that will get a kind of an understanding of what the parts look like coming off the tray after we've done a little bit of post-processing is cleaning them. So let me introduce you. So Jordan is our Vice President in charge of operations here. Matt Maloney, who is going to be doing our presentation, is our engineering manager. And again, my name is Justin Kutu, in case I didn't introduce myself, which I think I forgot. And I am president and owner operator of R&D Technologies. So without further ado, I'd like Matt to start his portion of the webinar. And again, if there's any questions, we encourage you to please put down any questions in the chat room and we will answer your questions accordingly. Thank you so much.
All right, thank you, Justin. Thank you everyone for coming and joining the webinar with us. As Justin said, I'm going to walk you through a little bit of what the J850 can do as far as the different capabilities. We do have Max over in the other side of the office here who has all the parts kind of laid out there, so you can kind of get a brief overview of kind of what we can do as far as colors go. But if any of you don't know what the J850 is, it is a PolyJet technology. So the PolyJet machines, they start off with a liquid photopolymer resin that gets cured with a UV light. It does run at a 30 micron layer height, so you get very, very high resolution, high detailed parts. It has, the 850 has up to 7 materials that you can run at a time. So that's how we're getting the full color. We get CMYK, there's white, there's clear, and then we also have a 7th slot for rubber-like. So you can start mixing rubber with some of the colors. As far as the build tray, the 850 is the largest machine that you can get in PolyJet. It's about a 500 by 400 by 200 millimeter build tray. So for those of you looking for the Imperial, it's about 19.3 by 15.3 by about 7.9 inches tall. So we've got fairly large tray that you can run a bunch of different parts on, either multiple parts of the same item, or if you're looking for just one much larger part that you're looking to do. You can mix and match different parts on the tray. It doesn't have to be just one part. You can run grips on one side, you can run full color on another side. So this kind of general rundown of what the 850 can do. So I'm going to hop in. I'm going to share my screen real quick here, and we're going to hop into GrabCAD. So everyone should be able to see my screen. So for those of you familiar with PolyJet technologies, you probably are familiar with the two material setup. So the higher end machines can run two materials at a time. Usually it's a rubber and a rigid, and you can mix them to get different shore values. And that's kind of what we're representing here. So just some basic parts on here. We've got a peeler that's got a little rubber handle on it, screwdriver handle that's got some rubber on it for the different grips, and then a flashlight that's been broken out into a couple different pieces. Mostly just for assembly reasons. So I've got these laid out on the tray. I pulled them in beforehand just because of the amount of files that I'm importing today. I've kind of already pre-brought them in, but we'll go through applying textures and applying colors and stuff like that to the different bodies a little bit later on. So what I want to show you here, what you're looking at is GrabCAD print. So if you've been on the older versions of the PolyJet machines, usually you're using Object Studio to kind of build up your trays, import your parts, rotate them, what have you. So what we've got here is on the left side here, we've got the print tray, we've got the schedule, and then we've got the history. So the history will just show you all the different trays that you've sent to the machine that have been printed. The schedule will look at, if you've got more than one machine, you can see all the different queues that are set up, when they're going to start, and you can kind of schedule your day around them, and then obviously the print tray. So for the print tray, if you have multiple machines, I've got all these loaded in. These are all the different machines that we have in our office here. Today we're looking at just the J850. So if you want to, you can download GrabCAD print for free. You don't have to own a machine in order to download the software. So if you want to kind of tinker around and play around with it, they do offer templates, so you can go through and set up whatever kind of machine that you want that Stratasys offers, to kind of showcase maybe if your part will fit on a tray. Maybe you can look at the consumptions as far as how long it would take to print a part and that sort of thing. And because we are a service bureau, if you do want to go ahead and set up a tray, say you want specific colors, you want specific orientation, anything like that, you could build a tray yourself, save the tray, send the tray off to us, and then that way we're printing it exactly how you want it to be printed. So over here on the right hand side is going to be basically our controls. So this is just the model view. You'll see that we do have some model errors. Usually this is when we get into the very complex parts. STLs, especially when you import them, will tend to have little pinholes or gaps or inverted normals or something like that. And that's easily fixable. So GrabCAD does have an internal STL fixer. So all I have to do is just hit here, repair all models. So you'll see that they're all green now. So the files are all set. You're not going to have any issues there. What's nice about GrabCAD is you don't have to save just the STLs either. So you can import step files, parasolid files, OBJ files, SolidWorks assembly files, SolidWorks part files, and that way you don't have to have that extra step of saving it out to an STL, especially if you have multi-body parts. You can just bring the whole assembly in, and as long as they're different bodies in the software itself, it will actually import with the different bodies applied. So that way, before you had to go out and you had to save the assembly, all the different STLs as different parts, and then import them separately, you no longer have to do that. So it makes life a little bit easier for anyone that's setting up the trays. So next down here, you have your units. So if I select this part, this is in millimeters. Say if I built this in inches, I can quickly and easily switch to inches. Obviously that's the wrong size, but usually STLs, they don't save a unit. So they save the dimension, but not the unit. So usually it'll be between millimeters and inches. And that's why you typically will see people, it's either going to come in really, really small and you need to step it up to inches, or it's really, really big and you need to step it down to millimeters. There are some cases where some people will billed in centimeters, but it's not too common. It's usually millimeters and inches. The next one down here, this is our tray settings. So these are all the different materials that we have loaded in the machine. For this particular tray, I have Agilis black loaded to get us that black rubber that you're usually used to on the Conics level machines, as well as all the different colors, clear, white, and then we've got the 706 support. You can set the different print modes. You do have high mix. That's usually the one that you're dealing with all the color on. There is a high quality mode. It does bring it down to 14 micron layers if you want really, really high definition parts. We tend to not see many people need that level of detail. Plus, it also brings up the time. It's usually about double the time because you're running it half the layer height. So typically we're running here in high mix mode. There is a super high speed mode and a high speed mode. Those you have to actually switch the machine into only 3 materials at a time. And basically what it's doing is it's using 2 heads instead of 1 to jet out a specific color, and that way it can lay down a lot faster. And that's how you get much quicker speed print times. So if I wanted to, I can go through here. If I didn't want to use Vero Yellow, I wanted to switch this to called Agilis White or something like that. Simply just move it over and add it. I remove this, bring this back in, and hit save. It's going to set up the tray. And if you had anything that was in yellow, so just for a moment, let's say this was in yellow. If I remove this and add Agilis White again, it's going to tell me that there's something that's wrong here, that one of the materials has actually changed. So you'll see that because we no longer have yellow, we can't make the green, we can't make the yellow, so it's going to automatically change these materials on us. So it is something to keep in mind. But where Agilis, I'm going to bring this back in, set it up properly. And this next one down, we've got our tray materials. So this is going to be selecting the materials. So as far as what you're looking at here, you can select by body. I've got a lot loaded in here, but if I go to these parts, you'll see that these were imported as an assembly. So I can select the whole assembly. Usually because it's an assembly, you're going to want different materials on the thing, but you can apply one color to the whole assembly. Or you can go in and you can go by body. So this one we've got set to the tray materials. So I just want this grip to be Agilis. So this is a Shore 30A rubber. And then for this handle, we want something that's going to be green. So I've got a couple of different options here. There's a color picker where it's just a generic color picker. You can change the hues, you can change the contrast, if it's white, dark, what have you. Just applying different colors to different bodies. This is an assembly. I can rotate around. So you've got typical 90 degrees. You can rotate it around if you want on the tray, if there's a certain orientation that you want. Typically, PolyJet will run with a support material under it. So if you take a flashlight from the top, anything under it that's in shadow will have support under it. So if you laid this flashlight front end here down like this, you're going to basically fill the whole thing with support. So better orientation would probably be to orient it like this so that you're not filling it with support. If you do have a specific plane that you want to run, they do have this option here, orient face to plane. And I can just click on a specific plane, hit bottom, top, left, right, whatever it is that I want it to be, and automatically orient it to that orientation. Now, what happens if I want to arrange this tray, it's probably going to put this down because PolyJet typically wants to lay everything as flat as possible and in a row as much as possible. But if I don't want that to happen, I can click on this part. I can lock it in place. So that's going to keep it where we want it. And then when I go ahead and hit arrange tray, it's going to shift this stuff around to whatever it thinks best. It's going to keep the taller parts over here on the left because the head's going to start up here in the top left corner and run across. So this is kind of the basic stuff. I'm going to bring you over to some heart models. So Max has a heart sitting on his desk in there. We've already built this part. It's in 3 different parts. Basically just a medical model to show what's going on in the heart. This was done with a scan where they've basically done a scan of a heart, imported into the CAD software, and created the different STLs for us. So I've imported these parts already, and we can start applying colors. So if I can select a color like I was before, where I can just select a random color and it will apply. If I already have a color and I know I want this color, I can copy the properties, paste the properties, and it'll keep that same color all across. And I can copy this, paste this, copy properties. And for these, we don't want them to be flexible, so we're just going to select these as short 38 rubber. Now, we do have other options. So we have the color picker, we've got digital materials. Digital materials will help us with our shore values. So if you know a specific shore value and you have 2 different materials that you want to combine to create that shore value, I'm going to select here the Agilis Clear and the Vero Black. And that's going to give us the regular Agilis is shore 30. So we start there. When you start mixing, you got 40 up to 95A. And then you've got a couple different polypropylene-like materials. So if I wanted to, I can come in here, I can do a digital material with the Agilis and white, or I can do black. Say I wanted a shore 60, apply. That's now shore 60. If I want this one to be a different one, I can do, say, the black, and I can do, say, shore 95, and it's going to be a little bit stiffer. So fairly simple, easy to do. If I wanted to go by a specific color, most of the designers out there will tend to have either a hex code, a Pantone code, a CMYK code. You can actually input those specific colors if you have a specific color that you're trying to achieve. J850 is a very nice machine in that it's actually been Pantone verified. So the Pantone colors will actually come out as you're as you select them. So here I've got a Pantone, and say if I wanted this to be a specific Pantone 2347, I can click on that, and it's going to give me that color. As I was saying, you can also go in here, you can select a specific hex color in here if you want. There's RGB codes, there's HSLA, and then also, if you want, if you're just going off the cuff, you can select a color here. This is going to be your hue. This will be your saturation, so your clear, or your transparency, sorry. So I can get this really, really transparent if I want to. And I can also select shore values. So if I want to, I can bring this down to, say, a shore 60 at this color. Now what's going to happen when you actually print the parts is the Agilis Clear is a clear material. So the softer you get, the closer you get to a shore 30, the closer it's going to get to clear. So it's going to be more of a tinted part. It's not going to be the actual color, but it's going to try the best that it can with the amount of rigid that it's mixing into the parts. So that's the rundown of kind of what we did with this model here. If I wanted to print this part, this is kind of how it came in. I wouldn't want to print it like this. I would want to orient this as flat as I can. So again, I can go in and rotate this with the face to plane. Hit the bottom, bottom, bottom. And then these will be nice and flat, so you're not wasting any support material. If I want to, I can simply duplicate. So I can duplicate this whole part. how many duplicates do I want to make? I can just make another one. Oh, sorry, I clicked the body. So I would have to find this assembly. Here we go. So if I select the whole assembly, duplicate, create, I can fit as many as I can on the tray. As far as STL imports, delete. I can import STLs as assembly. So if I want to find this part, this is part 3 of the heart. All I have to do is just simply take all these STLs, open, and then they'll all insert as an assembly. This is how it comes in with just the white. And if I wanted to, I can also disassemble it if it makes it easier for you to select the different bodies and change the colors. But we don't need to do that today. So we're just going to leave it like that. Now, these are kind of basic. These are color by body. So basically, any individual body that you have in your CAD file, you can select in here and create a different color, a different shore value, different material. There are different ways of doing this. So this is, again, color by body. You don't have to necessarily do it this way. You can go in, and if you have something like a key shot or a 3ds Max or something like that, where you can actually apply images and textures to your parts, you can actually pre-apply these textures to your parts, save out either a 3MF or an OBJ file, and you can directly import them. Now, right now you can only do rigid materials when you're doing the full color like this. But this is how you get very, very realistic models where you're trying to do wood grain, you're trying to do packaging, you're trying to do camouflage, leather, anything like that.
Jordan, can I interrupt for 1 second? We have a few really good questions that are coming into the Q&A
sure.
chat room. Not sure, do you want to answer these now? I don't want to completely throw you off, or do you want to we can handle some of these towards the end. Just wanted to see kind of how you wanted to do it for, your presentation. That's
sure.
all right.
No, it's fine. Yeah, hit me with a couple questions, and
so
that way it's a little bit more.
Jordan, are you in there? Do you want to? So we had a question. One was really good. It was the differences between the 750 and 850. So that was one of the first things I saw kind of come in.
Yep.
And seeing that we had a 750, which we upgraded to an 850 Prime.
Yeah.
Let's answer that one. It's a great question.
Yeah. So the difference between the 7 and the 850 is that it's the same overall machine as far as your build sizes and your quality and everything like that. It does have one less material slot. So you're running with 6 model materials as opposed to 7. So you would still be able to do full color like this, but you may risk not being able to do rubber with the color, or you'll be able to do rubber, but you can't do rigid clear with the parts. So what it would require is just another material change to get into the right setup that you want. So right here, these are typically what we're going to run with, because this is full color. You got your C, M, Y, K is black. You're going to need white to get that color to pop. And then with a 750, you'd have to usually choose between either Vero clear or Agilis clear. So either a rubber-like or rigid clear. May not be a deal breaker for some people, but it definitely gives us more flexibility, especially in a service bureau setting like we have, where people are constantly switching back and forth, and we don't have to do a material change anymore.
Yeah, it saves quite a bit on resin changes, that's for sure. Yeah. Another question was how clear, I think Jordan sort of answered it in the chat room, but how clear is clear?
So with clear,
when it comes off the print tray, so that's
right,
more specific, right?
So Max has the hand sitting in his office right now. That is a clear overmold. So if I go up to here,
certainly polished.
Right. So this foot is done similarly to this hand that he's got. where it's just a clear overmold with a bunch of different colors on the inside. What happens here is as the parts come off the tray, anywhere the support material touches the part, it's going to have a matte-like finish, so it's going to be kind of like a frosted glass. It can be sanded and polished and buffed up to get that full clear. The one thing with the clear models, especially if you're trying to do something like that perfume bottle that he's got, where it's just a big clear block and you want to see through it all the way, the clearest way to see through clear is from if you're looking at the tray top down. So that's going to go through the layers. You can be able to have the biggest clear, or the most clarity going from the top down. If you look at the sides, just because of the nature of the layering process, it is going to distort it a little bit, but it's not too bad. You can still usually see through the parts. It's just that it will be a little bit fuzzy, almost like something's a little bit out of focus, but it is definitely doable.
I had another question come in, and then we can kind of get you back going again, and then we'll kind of save some of these towards the end, if that's okay. But why don't, actually, some of these questions are really good. Why don't we going to hold on to some of these towards the end, but keep them coming. And what we'll do is have Matt kind of continue with his presentation, and we'll save some of the questions till the end. So we'll kind of hopefully you guys will have some specific questions towards your applications that you're working internally with on your manufacturing course, and we can hopefully get some questions answered and move on from there. So sorry, let's go, Matt.
No, there wasn't too much left, but just a quick rundown here. So what you've got is, like I was saying, you can apply different textures in KeyShot. You can apply it in a bunch of different softwares, as long as you can save out. Usually an OBJ is going to have that color information on it. And that way you can do bump maps, you can do images here if you want to do like a sales model or something like that, as like a one-off, or you need to pass it off to marketing, or they need to sell it somehow. That way you get the most realism out of the parts that you can, and you don't have to sit there and either do a very short run manufacturing of the part, or have someone sit there in a model shop trying to paint this thing or do anything crazy with it to get it to look as close as possible to the final model. And you can also iterate with all of this stuff too. So, if I wanted to have different colors on this part, say I wanted to make this magenta or something like that, you can still do that, and you don't have to sit there and spend all this time. You can do them all in the same tray, or you can just run one part, see if it looks good, change the color, change the sizing, what have you. You can scale it down if you want to. So for instance, I can scale this down to, say, 90% and just scale the whole thing down real quick. And that way you don't have to start from scratch with a new model. So that's most of what I've got. So these are all different medical models. What you're seeing here is a bunch of different parts of the body, where these purple parts are actually the tumors in the body. So what they're doing now for medical models is, before they go ahead and they do a surgery, if it's something that's really, really difficult to do, they'll actually they'll take a scan of the body that has the tumor, how it is in the body. It's not like, they're going in blind or anything like that. They print this up, they can take a look at it, they can put it in their hands, see what they're looking at, how they want to attack it, what the best way is to go in, and maybe they need to cut over 2 inches from here, angle it in this way to get at it. And so it's helping a lot of the surgeons kind of figure out how they want to attack these different problems, especially the more risky ones. And that way it's not like they're opening up the person for the first time and then trying to figure it out on the fly. So it's a lot less riskier to kind of have that knowledge ahead of time. And that's certainly something that we definitely appreciate, helping the different medical fields out with, as far as trying to attack some of these issues. So you can see here that I've got a big tray. This is probably more than what most people would be doing. But let's just say that I want to print this tray. I can estimate this out. So this might take a little bit. We'll see how quickly it goes. If it's not too quick, I'll have to go back to the basic tray. But this will basically go through, figure out how much material it's going to use. So all the different colors, all the different Agilis and everything like that, support material. And it's also going to tell you how long it's going to take to print. So this will help you as far as building a use case for buying the printer, if you're looking to buy a printer, or just the time that it's going to take, so that you know, hey, this is going to take a day and 15 hours to run. Hey, you know, do I run this over the weekend? Do I run it now? And so this way you can set it up, see what you're dealing with as far as cost goes, as far as time goes. Maybe you need to scale something down to get it in your budget or something like that. And then you can go ahead and print it. Now, if I want to print this, it's going to pop into a schedule. We've got a bunch of different printers here. This is everything that we have. And basically it's going to set up a queue. So your queue, say this job, it's going to run until 3 a.m. right? So you can actually set up your schedule. So we've got it so our hours are 8:30 to 5. And it will actually push the next tray until the next business day starts. So that way you can set up your schedule, know kind of when you need to flip trays, if someone needs to come in overnight, over the weekend, what have you. And you can also move them around. So if you have multiple trays down here, you can actually move the job left, you can move the job right, you can delete the job. And the nice thing about GrabCAD is you can hook it up so that it is in the cloud, so that if you have people that want to adjust the queue or work from home, they can actually send jobs from their computer to the server, and then it'll automatically go to the machines. So you only need one person at the office to just basically take the parts off and restart the tray. They don't necessarily have to be there and do everything at the machine. They can do it from they can look at it from their phone if they want to. I don't think you're gonna be slicing anything from your phone, but they can certainly slice it up on their laptop at home or the computer out in the office, 2 floors up or something like that. Send everything to the queue, and then your queue manager, your printer can look through and say, okay, well, I want to combine these trays. Or they can just send the tray file to whoever is setting that up. And then that person can combine the trays if they want to and set up the queue however they want. So I think that pretty much covers most of what I want to go over. Obviously, there's a bunch of little intricacies that we can probably get into, but I don't want to bore you guys too much to death. And I think probably better just to see what questions everyone has. So Jordan, you want to hit me with some of those questions?
Yeah. So if anyone has a specific question, you can use the raise your hand feature in here, and we can certainly allow you guys to have a conversation with Matt or us live. While we're waiting on some of those, we had a couple of questions that we can go into more detail on. Bob asked if we have a cavity within a model, does the software traditionally fill that cavity with model or support material?
Good question. So what's going to happen is it is going to fill it with support. That's just any sort of void in the part is going to have support. It's technically in that shadow region. So it will fill it with support. If you don't have some sort of access to it, either a hole that's been drilled in or something like that, it's going to stay there. You're not going to have too much of an issue as far as it's not going to like leak out or do anything like that. You should be fine just keeping the part as is. Now, if you have a clear part and you have a void like that, obviously you're going to see it inside there. That may or may not be advantageous to what you're looking for. But you will need some sort of access to get it out. The 706 support is a soluble support, whereas some of the older machines only run on the 705 support, which you physically have to scrape off with either a water jet or just manually picking at it. It is a fairly slow process though. So yes, it will eventually clear it out. but it's always better if you can physically and manually remove it first.
Matt, if someone doesn't have a Stratasys printer, can they try GrabCAD without purchasing?
Yeah, they should be able to download it for free and load it up. I know we've had a couple companies that had some special cases where they wanted to set up the trace for us, where they had all their colors and stuff like that already applied. So you should be able to download it for free. You will have to create an account for it, but you don't have to own a machine. And like I said, it'll give you access to a bunch of different templates. So if you wanted to mess around with an Object 1000, a 260, even some of the older machines you can load up. But you can load up a 750 and 850 and just mess around with it, add colors, see what the times are, see what the estimates and consumptions are going to be like, just to kind of get a feel for it.
Matt, if you could, I'm going to turn off your screen share for a moment.
Yep.
And we're going to spotlight Max.
Yep.
So Max is in our conference room. He's got all the models here. Max, if you could please, we had a couple of questions in regards to texture. If you could maybe pick up the shift knob there and kind of get that close to your screen. So that shift knob has a leather-like material with digital stitching. So that would certainly be an instance of being able to apply textures. You can do wood grains, things of that nature, layering in all those different items. So that's a good example of being the layer in textures and whatnot into specifics, for your models if you're looking for that kind of capability.
Yeah, something like KeyShot, you can do a bump map fairly easily with, and usually you can even download some mapping features from Google or whatever to get you kind of like the generic and basic bump maps. Was it about actually applying textures, or were they looking for textures as it comes off the machine, Jordan?
More of an example of what they look like.
Yeah.
Another question that's on here is, can you select the grid material that goes into the support?
Yes. So with, let me share my screen again real quick. So if you want to change the grid support on the parts, you'll see that we have a matte finish here, matte and glossy. There's more settings. And so there are support options here for the different strengths of support. There's 3 different ones. You've got light, standard, and heavy. The one that you're usually used to, especially with the older machines, is going to be standard grid, which the support is basically putting a grid of model material in there to keep it somewhat strong. It doesn't matter too much if you've got some big parts like this that there's no thin walls or anything like that that's too high. Because the support material is gel-like, so as you're printing and running across it, it will have a tendency to flex and bend if there's not any sort of structure to it. So if you've got really tall parts, really heavy parts, you'll want to use heavy grid. That'll put more model material in it. Standard is kind of the generic standard, and light will keep as much of the model material as it can out of it, which helps with the soluble support, getting that off of it. And it uses less model material, which does save you a tiny bit of savings there. But it can be a little bit easier to clean off, especially if you have internal geometries where some of that model material will kind of gunk it up in there.
So he's correcting, the question was corrected, not the grid weight of the support, but what was the,
rather the color of the internal grid.
Oh, yes. So pull back to this real quick. All right, so standard. There should be an option in here. I know they added it. I don't see it. I remember that in the notes that they had it so that you could change it, but I don't know why it's not letting me do it. It's just saying default here. So it may not be. I'm going to have to check with GrabCAD on that, because I know it was definitely in the release notes a while back, actually, that you could change it. So I'll have to check with GrabCAD on that. Do we have his contact information?
Yes, we do.
Okay. Yep.
And again, if anyone wants to, speak to their question, feel free to just use the raise hand feature at the bottom of the screen, and I'll be happy to unmute
Good
you.
question here, Jordan. If they have, Matt, obviously you guys can answer this. Is they don't have a Stratasys printer, but are they able to test GrabCAD? Are they able to download it without purchasing it?
Yeah, they should be able to.
And is there a link or something that we can provide? Is this? Do you suggest a site to go onto? Is it more Stratasys?
So I believe it's GrabCAD.com.
But I know you can use it without it's
Right.
non-licensed software, so I know you're able to use it and kind of get an understanding of it for free.
Yeah, so you can go, it's just GrabCAD, so GrabCAD.com/print. And like I say, you do have to sign up for an account, but you can sign up for free, and you don't have to have a machine or anything like that in order to play around with it.
Okay. Another question was material costs. What are getting into the 850? Do the material vary as far as costs go?
No. So what Stratasys did with the 850, I'm actually going to pull this up real quick. So what they did with the 850 is they actually, before all the different materials kind of had their own slightly different price. Now it's all straight across the board. So your support is going to be $420 for a 4 kilogram slug. And the model material, I believe, is $1,200. Yep, so $1,200 for all materials across the board for the 4 kilogram slug. The one outlier to that would be.
So they've actually lowered the cost on the containers of material from the 750 to the 850.
Right. So what happened with the 750 and the old Connex level machines was they were a 3.6 kilogram slug, and the pricing now is about the same for most materials, and you actually get that extra 0.4 kilograms of a slug of material. The other thing with the 4 kilogram slug update is that the spout is actually at the bottom more, so it doesn't have to suck it through the straw. So before it would only go down to about 100 grams or so before we tell you to replace the canister or the slug. The 4 kilogram slugs, it will actually go down to 20 grams. So you can use that little bit extra more out of the container before you have to toss it.
All right, so Matt, I'm gonna stop your screen sharing and put it back to Max here. We have another question in regards to printing. Are all the 3D printed models that you're showing post-processed in-house? And do we have a detailed post-processing protocol for each model available? So yeah, everything that you're seeing here was printed, on our 850. You've got a couple of different models there, where there has been some post-processing that's been completed. Max, if you could pick up the perfume bottle there. Thank you. That's one where, this is using the ultra clear feature of the J850 with some post-processing. Post-processing is basically just, sanding with some, fine grit sandpaper, and then you can do some processing, directly out of our back room. We can handle all that for you. You don't need to get your printed parts and then go seek a secondary post-processor. We have those capabilities and can quote those jobs for you directly. So that, as far as the 850 capabilities of ultra clear, this is a great example of that. Max, if you could also show the Lenco truck.
I'm just going to jump in quick. We have some very experienced Connex, PolyJet Matrix users on the call here with us. So if you do want some more detailed ways of post-processing, we're happy to kind of explain that to you. Other than just a simple, using a low grit, wet sand and automotive clear coating, there's a little bit more detail into it that we use internally. But that's something that we can take offline and kind of give you some more information on if you have some questions about doing medical models, or just high-end detailed kind of consumer product type stuff. So I noticed some of the questions are coming from people that have some very high-end knowledge of this industry. So happy to work with you guys and give you some more information about that offline if that's something you want to talk about more in depth.
And Max, if you could also bring the medical model that's been post-processed on the left, a little bit closer to your screen. Nope, the clear one.
Nope, the clear one.
Thank you. Just to show the full capability, being able to see the detail, and then you can flip that over and see the veins and channels all the way through the clear material. That's certainly a good example of a part that's been encased in clear and then post-processed. Matt, another question. Can the rubber-like material have a different feel all the way up the handle?
I think I would need a little bit more information from that question. So the shore values that you select will be throughout the part. Now, it will have a different feel depending on the thickness of it as well. So you might have a Shore 95 that you can flex somewhat if it's maybe 2 millimeters thick, but if it's like an inch block, it's not going to flex a whole lot.
But if you're doing a coating on the handle, you can do different grip simulation based on if you're assigning different properties, I think is
right. So if you do split it up so that the bodies are that you do have different bodies that you can apply those different shore values to, you can change it. There is no way to do like a gradient where it's one body and you start at like 30 at one side and 95 at the other. But yeah, if you have the body, you can select one shore value at a time. And depending on the thickness, it may feel a little bit different, but it's still a certain shore value that you selected.
So another question was, how do you capture the patient's data and convert it to an STL or something that you want to print? So how is that information captured for when you're dealing with a patient and for medical models?
So we don't do that internally here. We do have a separate company that will do that for us. There's a lot of patient confidentiality and all that kind of stuff that goes into it. Essentially, the program is taking a CAT scan, which is already done in layers, and creating a point cloud to create the STLs for the part. So in a sense, it's pretty much a scan, but it's using that CAT scan data to create the models. And then once they create those files, they're separating it out into the different bodies. So there are specialized companies that are doing that processing of the files. Depends on who you're dealing with as well. So there are companies out there that will do it, and they will keep everything confidential, so that there's no patient tags or anything like that to it. But it can be done. We can get you in contact with those companies. We are partnered up with at least one. So we'd certainly be able to help you out with that if you want to go look further into it.
Right. I'm not sure.
We got another question. CT or MRI to STL file conversion can be extremely labor-intensive process. Yeah, so that's in that area. That's why we partner up with certain companies to produce those files. So it's certainly something that we can, partner up and provide some outreach for, to produce those if that's an area of need. We had a quick question from Charlie. We'll be showing the J850 in action. Our J850 is currently in action. It is producing parts for a customer at the moment. With that, of course, our our customer that we have parts that are being produced currently right now is under an NDA, so we can't show the parts that are currently being produced. Our service bureau is a 24-hour-a-day operation, so we're constantly creating parts, and unfortunately, for our webinar purposes, it's producing parts at the moment that are under NDA, so we're unable to show what's on our current tray.
Yeah. So
lots of videos online that you can take a look. So if you do want to see a J850 in action, anybody that's on the call, and certainly we encourage you to go onto Stratasys.com. They'll show you the 850 running, but lots of YouTube videos on it as well that you can kind of check out some more information. And then of course, everyone has an open invite to our facility. If you want to talk to us offline and you're interested in coming down and seeing the machine in action, we're happy to set up a little tour of our shop, kind of give you an understanding of all the different PolyJet machines, PolyJet Matrix machines, the slew of FDM machines that we have, that we are happy to kind of walk you through and give you a bit more of in-depth technology kind of tour of. So
we also have our open house video available on our YouTube channel, which will show the J850 in action, as well as a lot of the other FDM machines that we have in our back room. One last question that came in is, Matt, can you briefly go over the pros and cons of having a large machine like a J850 versus, say, an office-based machine like a J55?
Yeah, so as some of you may know, there's different levels or sizes of these machines. For a while there, it was only the large sizes were capable of doing full color. They do have some smaller machines now that can do full color. Now, as far as the business case, obviously it depends on how much you're going to run the machine. So if you need to run a lot of parts or you need the size, obviously you're kind of stuck with maybe going with an 850, or you end up having to split your parts into multiple parts to assemble later, depending on how large they are. Something like the J55 is a little bit smaller, and especially the 55 is a little bit of an oddball because it's more of a donut shaped ring. Let me see if I can pull up the 55. Let me share my screen real quick. So this is a J55 tray. A little weird because it's a donut, but obviously, you're not going to be able to fit as many parts on the tray. So it all depends on the budget that the company has for the type of machine. The other thing with the smaller machines, I believe right now, is that they do not offer the rubber-like materials with the full color. So you will have to, you'd only be looking for rigid full color material properties as opposed to being able to do the rubber-like and full color. So the machines all have their own slight differences in specifications. So it would definitely be more of a discussion to have offhand with the team to figure out kind of what suits your needs a little bit better. And worst case, something like this, if you are looking at a machine, typically what we say is, find a machine that's looking for, that's going to help you out with maybe 80% of what you're trying to run, and that other 20% that you have, edge cases for or something like that. We are a full bred service bureau, so we can run those parts for you if you need to, and that way you don't overspend on a machine just for a couple of those few edge cases. So
Matt, we had a question in regards to the speed per cubic inch on the J55 in comparison to the J50. From a cubic inch perspective, we may need to follow up on the specifics on
right.
It is possible for us to do an estimation based on this.
I was gonna say,
and then you can flip it back over to the 850.
Actually, I'm gonna just start a new project. So so I'm not tied down. Import STLs. It's fine. That's fine. So I'm just going to bring in this file real quick and do an estimation of the part on this and the 850. Because it is a little bit, I want to say that the 55 might be a little bit quicker because it doesn't have to stop. Basically, because it's constantly rotating in a circle, it doesn't have to stop at one end and then come back. So if I estimate this real quick, this is a roughly 2.2 by 2.2 by 0.8 inch part. You'll see that it's a 3.5 hour build. And then if I switch this over to the 850 template, do the estimation. The other thing is if I had multiple rows going down this way, it might change a little bit. So that's about an hour savings on the 850. But if I duplicate 10, ooh, no. That's not what I wanted. It's chugging a little bit. So I do an estimate of 1, 2, 3, 1, 2. So that's 9.5 hours for 24 versus on the 55. I'm not going to be able to fit all of them. 1, 2, 3, 4, 6, 7, 17. All right. Are there any other questions, Jordan, while I'm doing this?
Let's see. So we just had a comment. This is an old estimate for older machines, but there can be up to an 8-fold print time difference for an Object 30 Vero clear part versus a Connex 50 Vero clear part. So certainly, larger time differences between the Object desktop machines and certainly the larger industrial machines that we're running.
So 10.5 for 17. And what you may have noticed is that you can build out a project. So I'm building in a project right now. I can set up multiple trays within that project. That's how I was going between the different trays with the simple, the medical, and all that. Yeah, so it looks like it's quicker on the 850, which is a little bit surprising to me. But I haven't messed around with the 55 too much. So that looks about 2 hours quicker on the 850 for the same amount of parts.
Yeah, so certainly though, if you're looking to produce multiple models, the 850's build tray allows for the set it and forget it capabilities of being able to set a tray and leaving it overnight. Much of like what we do out of our service bureau to provide you more capability and less hands-on requirements to produce parts. The J55, the J826 are great machines if you are looking for a smaller version and still staying within the PolyJet family that Stratasys has to offer. So certainly, if you're not looking to go full J850 to have an industrial size machines, the 850, the 55 and the 826 are great models that our sales staff certainly can get additional information to you if you want more. So with that, looks like we are at the hour mark. We are out of questions. So I guess Matt, tremendous job. Thank you very much. And we'll throw it back to Justin. Close us out.
Yeah, thank you, Jordan. Hey, Matt, excellent job. Appreciate it. Max, good job with the parts as well. I know the gimbal was a little shaky, but I think we got the point across, and hopefully the models gave everybody a better understanding of what the machines can do. And it's not really a smoke and mirrors thing, that these are real parts, real medical models, and make a real difference in all industries as far as I'm concerned, and many other companies that we work with as well. So I wanted to thank everybody for their time. I encourage all of you, if you have further questions with regards to anything that you saw today or different technologies within the Stratasys umbrella, that we're here to help you on all things additive manufacturing. Look forward to hearing from everybody soon. And I will certainly have my emails going out with a thank you with my contact information later today. And you are welcome to contact me for anything at any time. So that's really all I have at this point. Jordan, thank you again for all your help with our Q&A sessions as well. And, wanted to have everybody have a great day, and hopefully we hear from you soon. Stay safe. Thanks, guys.
Thanks, guys.